Good afternoon, students. Let us continue the yesterday topic about relation. Now, the yesterday already I have told you about the equivalence relation. Any relation on a known empty set A, which is reflexive, symmetric, and transitive, is called an equivalence relation. In other words, an equivalence relation R satisfies the following condition. Number one, every element of A is related to itself if AA belongs to R for every A belonging to R. Number two, if AB belongs to R, then BA must belongs to R for AB belonging to A. If AB belongs to R and BC belongs to R, then AC belongs to R for ABC belonging to A. If a relation satisfies all the three conditions, it means it is reflexive, it means it is symmetric, and third, if it is transitive, then the relation is said to be equivalence relation. Let us see the question based on this. Now here the first question here, if R is a relation on R, if R is a relation as R equal to AB, where B minus A equal to 2 and B greater than 4 on the set of natural number, then write R in the roster form. We have to given the relation in the set builder form. Condition is given, the difference must be equal to 2 and B must be greater than 4. Then we have to write R in the roster form. Now R equal to AB, B minus A equal to 2, B greater than 4. Now AB belongs to R and therefore A can be written as B minus 2 and B must be greater than equal to 4. So it means we have to consider the element. First element I have taken here, ordered pair it may be, we starting from if A is 3. Then if A is 3, then B must be equal to 5 and B is what? Greater than 4. Now we have to consider all the pair, the difference should be 2 and starting from what? B greater than 4. So first pair will be 3, 5, then 4, 6, 5, 7, 6, 8 up to infinity because n is a set of natural numbers. So this relation is also infinite relation. Now here the next question is here. Prove that R given by this xy, x belongs to A, y belongs to A and xy modulus of x minus y greater than equal to 0. We have to prove it is a universal relation. Universal relation means the largest relation. It means all the elements belonging to A, they must be related with itself as well as related with all the other elements. So now here A cross A. Now consider A cross A will be what? XX, XY, YX and YY. These are the possible ordered pair that can happen in A cross A. Now here our relation is what? X minus Y, modulus of X minus Y greater than equal to 0. And we know the difference of two elements, modulus of difference of two elements is always greater than equal to 0. Now here as X minus X greater than equal to 0, X minus Y greater than equal to 0, modulus of Y minus X greater than equal to 0, modulus of Y minus Y always greater than equal to 0. It means all the elements of A cross A satisfy modulus of X minus Y greater than equal to 0. Therefore, R is what? Universal relation. It means R equal to A cross A. So, therefore, R is what? The universal relation. And now the third question is here. This type of question can be asked in 1 marks question in the board exam, in which we have to just satisfy only one property or one relation. Determine the relation R on Z defined by R equal to AB, modulus of A minus B less than equal to 5, AB belongs to Z. We have to determine either it is transitive or not. Now we have to prove that either it is transitive or not. It is not mentioned here, but the question is here. We have to check either this relation is transitive or not. Now, whenever the relation it is not transitive or it is not reflexive or it is not symmetric, only you have to take one pair. We say that that pair does not satisfy the condition, so it is not transitive here. Now I consider the elements. I have considered order pair 1, 5 and 5, 7 because A minus B less than equal to 5. 1 minus 5 pair I can take the difference is what? 4, so less than 5. Here the difference is 2, again less than 5. I consider the pair 1, 5 and AB is what? 1, 5 and BC is what? 5, 7 belonging to R. Now here, when I consider 1, 7, does not belong to R because the difference is what? 6. Our difference should be what? Less than equal to 5. So 1, 5 and 5, 7 belongs to R, but 1, 7 does not belong to R. So R is not transitive. You can give another example here also. You can choose any example and you can show it in the solution. Now the next is here. The question is R be the relation in the set this given by this. It is given. Prove that R is reflexive and transitive, but it is not symmetric. Now A is 1, 2, 3, 4 and the relation is given. All the ordered pair is given. So therefore, first clearly as for every A belonging to A belongs to R because 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4 is there. It means every element of A is related to itself. Therefore, R is reflexive. Now here the second point we have to check the symmetricity. Now as 1, 2 belongs to R but 2, 1 is not there in R, so it is not symmetric. And the third is here we have to check the transitivity. Now transitivity, let us check for all the pairs. Now 1, 2 is there, it means AB is and this is BC. AB is there, BC is there. Now 1 is related with 2, 2 is related with 2. Again 1, 2 is there, so it is what? This pair is transitivity. For next pair does not happen. Now here for this again not happen, we have to check AB and then BC. Now here the next is here, consider 1, 3. 1, 3 is there, 3, 3 is there, again 1, 3 is there. For this pair it is what? Transitive. Again for the next is 3, 3 is there, 3, 2 is there. Again if A is related with B, B is related with C, then A must be related with C and again 3, 2 is there. For those pair where if AB is there and BC is there, then again AC is there in R. So we can say this relation is what? Transitive relation. Therefore this is what? The transitive relation. Now here the next question is here. Show that the relation R in the set of real numbers defined as R equal to AB, A less than equal to B is reflexive and transitive but not symmetric. Now here the condition is A less than equal to B. Relation is defined on set of real numbers. Now the relation is A less than equal to B. Every number is equal to itself. Now A less than equal to A is true for all real number because every real number is equal to itself. So we can say as A belongs to R for every A belonging to R. So it is what? Reflexive. Similarly for what? The symmetricity. Now let AB belongs to R. This implies A less than equal to B. But A less than equal to B does not imply B less than equal to A. It is not possible. If A is less than equal to B, then B cannot be less than equal to A. It means if AB belongs to R, BA does not belong to R. You can also quote the example. Here, therefore, R is not symmetric. Now for the transitivity, let's consider the pair AB and BC belonging to R. If AB and BC belonging to R, this implies A is what? Less than equal to B. B is what? Less than equal to C. Now if A is less than equal to B, B is less than equal to C. This implies A less than equal to C. This implies AC belongs to R. Therefore what? Therefore R is what? Transitive. In this question we have to prove that this relation is reflexive and transitive but not symmetric. So we have proved it. Now here let us see the next question. Let L be the set of all lines in a plane and R relation is defined L1 L2 where L1 is parallel to L2. Show that R is an equivalence relation and find set of all lines related to y equal to 2x plus 4. Now here let us see the solution. We have to prove that is an equivalence relation. Therefore we have to prove that this relation is reflexive, number one. This relation is symmetric and this relation is what? Transitive. All the three conditions must be satisfied. Then we can say R is what? Equivalence relation. Now here, as every line is parallel to itself, therefore L1 parallel to L1 implies L1 belongs to R for every L1 belonging to R. Therefore R is reflexive, or you can easily write as every line is parallel to itself. So we can say R is reflexive. Second is here, we have to prove the symmetricity. Let L1 L2 belongs to R. This implies L1 parallel to L2. If L1 parallel to L2 implies L2 parallel to L1. This implies L2 L1 belongs to R. It means R is symmetric. Then the third is what? The transitivity. Let L1 L2 and L2 L3 belongs to R. Now this implies L1 parallel to L2. This implies L2 parallel to L3. This implies L1 parallel to L3. This implies L1 L3 belongs to R. So this relation is transitive also. Therefore all the three conditions are satisfied. So we can say R is what? Equivalence relation. Now the second point of the question is here. We have to find out the set of the all lines related to this. It means set of all lines parallel to this line, because the relation is we have to find out the parallel lines. So therefore the set of all lines related to y equal to 2x plus 4 can be written as y equal to 2x plus k, where k belonging to R means any real number. Because if the two lines are parallel, if their coefficient of x and y are the same, this we have learned in the 11th class in the coordinate geometry. If we are changing this k, we are getting the lines parallel to the given line. This type of question can be asked in 4 marks question in the board exam. Now let us consider another question of this type. Show that the relation R on set A, x belonging to z 0 less than equal to x less than equal to 12, given by R equal to AB, where modulus of A minus B is a multiple of 4, is what? Equivalence relation. Again we have to given this set, and this relation is defined. We have proved that it is what? Equivalence relation. Now see the solution. For every A belonging to A belongs to R, because modulus of A minus A equal to 0, and 0 is what? Divisible by 0 is what? Divisible by sorry, let me explain it again. Now see the question again. For every A belonging to A belongs to R, because the difference of same element is 0, and 0 is what? Divisible by 4. Therefore it is what? Reflexive. Now here let AB belongs to R. This implies A minus B is a multiple of 4. Now consider B minus A. B minus A can be written as modulus of minus A minus B equal to what? Modulus of A minus B. If A minus B is divisible by 4, therefore B minus A is also divisible by 4. This implies BA belongs to R. Therefore R is what? Symmetric. Now see the third condition. If AB and BC belongs to R, but this implies A minus modulus of A minus B is the multiple of 4, and B minus C is also the multiple of 4. So I have considered modulus of A minus B equal to 4m and modulus of B minus C equal to 4n. Now here it can be written as A minus B equal to plus minus 4m, and B minus C can be written as plus minus 4n. When you remove the sign of modulus, we always put the sign of plus minus. A minus B equal to plus minus 4m and B minus C equal to plus minus 4n. Now we have to consider AC. Now the modulus of A minus C can be written as modulus of A minus B plus B minus C, because A minus C can be written as A minus B plus B minus C. Putting the value of A minus B and B minus C here, 4 common, plus minus m plus minus n. We can take 4 outside. It is 4 into modulus of plus minus m plus minus n. This shows modulus of A minus C is what? Multiple of 4. So it must be divisible by 4. This implies AC belongs to R. Now therefore R is what? Reflexive. It is symmetric. It is what? Transitive. So we can say that R is what? Equivalence relation. Now the second part of this question is we have to find out all the set of all the elements which is related to element 2. It means we have to consider another element, so their difference should be what? Multiple of 4. So the answer of this question is what? The set of all the elements of A related to 2 is 2, because 2 minus 2 is what? 0, divisible by 4. It may be 2, it may be 6, it may be 10. Next element we cannot take because our element is up to what? 12. So therefore the set of all elements of A related to 2 is 2, 6 and 10. As modulus of x minus 2, it must be the multiple of 4. Modulus of x minus 2, it may be 0, it may be 4, it may be 8, it may be 12. And it gives the value of x equal to 2, 6 and 10. This is all about this question. Tomorrow we should consider another question from the